because obviously that's what you want to do on Saturday morning. Yes, I have code, but I also have other words. Lots of words, far too many words. So this 90-minute talk, right, so there are a bunch of principles I would really love to explore. If we're lucky, we'll get through 4. If we're not so lucky, we'll get through 3. If we're really unlucky, it's going to be down to 2. But I will go at a speed that is not entirely unreasonable. If you watch YouTube 1.5, should be good. Okay, so yes, good morning. My name is Kevin Penny. I am all over the place. I can't give up keeping track, but Kevin is fairly internet unique, so you can find me in various places. Geographically, Bristol. I work for myself, and I run workshops and do bits of consultancy and do talks. And I have been doing this for a long time. The white hair is not simply a result of compilation issues. So I want to talk about some of these things today, having a deep historical basis. So let's first of all, I've got 2 words in the title. I'm not going to give you a breakdown of my name. So we'll just stick to the 2 words. Principle, right, what do we mean by principle? A lot of people launch in immediately say, yeah, we've got principles. Yeah, very few words have single and ambiguous meanings. So let's explore this. A general scientific theorem or natural law? No, that's not the one. There's nothing about software that really submits to this, except when you have network problems and you run out of disk space. That's where physics starts coming in and going, a rule or code of conduct? Yes, and I can tell you these slides have passed the code of conduct, or at least an early draft. A fundamental truth. I'm sorry, in software we don't deal with fundamental truths. A fundamental assumption. Oh man, software is all about assumptions. And there are stacks of those around principles, which leads to a lot of misunderstandings. Let's understand this word. A failure to understand something correctly. Yeah. Misinterpretation. Absolutely. Misconception. It's even deeper. Yes. A disagreement or quarrel. Oh, yeah. A lot of the principles that people say, these are principles, we use solid. Really? You have no idea what you're doing. Right, first provocative statement of the day, other than it's Saturday morning. So, a number of years ago, I was very much part of the patents community, wrote a couple of books in this space. A lot of what people call principles are actually patents because they are contextual pieces of advice. A principle is something that is universally and generally true. They are contextual pieces of advice. Who here is from outside the UK? Okay, which way do you look when you cross the road?
Right.
What do you tell your kids?
Right.
Yeah, so this is the whole thing, is that that's a contextual piece of advice. Okay? And normally we don't qualify with context. But when I brought up my kids, I wasn't there going like, okay, first of all, establish the direction of driving in the countries that you are in. What then? No. You normally just give it and the context is implicit. A lot of advice that we dish out to people and label as principles actually is contextual. But there's a different thing that matters here. Because this isn't just about coding style, this ultimately affects our architecture. It becomes the substance. You do a small thing lots, guess what? It becomes a big thing. So, let's start with DRY, which stands for?
Repeat yourself.
Bingo. Well done. Well, that was hard. Let's trawl the internet. You might be familiar with the DRY principle and so you might. It encourages the reduction of code duplication, which often leads to more maintainable, efficient, and less error-prone programs. Nice. This was written pre-AI. Otherwise, you'd be delving into something I'm sure that's fine. Don't repeat yourself. DRY is a software development principle that encourages developers to avoid duplicating code in the system. Okay, cool. DRY's principle of software development aims at reducing the repetition of patterns and code duplication in favor of abstractions and avoiding redundancy. Okay, these are all saying something that is pretty much the same. The DRY principle comes from Pragmatic Programs, Andy Hunt and Dave Thomas. And Pragmatic Programmer, wonderful book. This is my copy of the second edition, which came out 2020. And they talk about the DRY principle. Let's get something out of the way up front. In the first edition of this book, we did a poor job of explaining what we meant by don't repeat yourself. But it's very rare to get a second edition to actually say, it kind of breaks the fourth wall. It's just like, yeah, sorry. What did they say in the first edition? So here's my copy of the first edition, came out in 2000. Every piece of knowledge must have a single unambiguous authoritative representation within the system. That's not too bad. That's a good summary. It's, but you want to double click on this. They didn't just leave it at that. And they gave a number of examples. But the thing is, people gravitate towards the things they can immediately understand. And that is what gets communicated. So, what we end up with is, many people took it to refer to the code only. They thought that dry means don't copy and paste lines of source. Now, that is part of dry, but it's a tiny and fairly trivial part. Now, a few years ago, I edited this book, and you can find various repos around because I made sure I had an open source license. 97 things every programmer should know. And Steve Smith actually gets this pretty much right and wraps up and tries to relate dry principle to other principles. The one many people are actually related to is what comes from extreme programming, once and once only. OOA, if you would like some pronunciation to go with that. Which applies only to the functional behavior of code, and we thought of it as a subset of dry. So yeah, dry is not quite what people think of it. It's about the duplication of knowledge, of intent, which clearly relates to code. It's about expressing the same thing in two different places, possibly in two totally different ways. Now, point about this one. Do you have to change code and documentation, or a database schema and the structure that holds it, or whatever? If so, your code isn't dry. Suddenly this puts a very different spin on it. You suddenly realize that none of you are working on a system that is dry because of the limitations of our frameworks or languages or other architectural constraints. It's not really just about the code, but even if you made your code non-duplicated, you would actually find that many of these decisions are outside your hands unless you want to go and fork your own open source project to eliminate this. But it's a deeper principle. And in other words, there's an element here that runs far deeper and is, as I say, beyond your control. So yeah, feel free to pursue dry, but do try and talk about code duplication as not a violation of the dry principle, although it is. Focus on what it actually is. It's code duplication, and we generally don't like that. Okay, it's okay to use just words that aren't fancy abbreviations. Like information hiding, which is not a fancy abbreviation. I have seen some people try and refer to it as IH, but you really can't pronounce that. Hiding information is high, but we never went that path. So, familiar with information hiding?
Is that encapsulation?
Oh, that's kind of, wow. I mean, this was QI, isn't it? It's related. Well, a lot of people equate it with data hiding. Okay, and that's the way it gets, because data and information are kind of related. Data hiding relates to data abstraction. And this is a Python conference. I haven't said anything rude about Python programmers this morning, so let's start. Honestly, Python programmers suck at data abstraction. Ooh, I'm going to make everything public. Oh, double underscore's a bit hard. Oh, my fingers, I can't do it. No, I don't subscribe to that. So, let's talk about data abstraction. Because it's not the whole story, it's part of the story. But let's understand data abstraction before we say, by the way, it's not the same. It's a superset, subset relationship. So data abstraction. Data abstraction is a valuable method for organizing programs to make them easier to modify and maintain. I'll just throw an extra sentence in here to give this a bit more context. Inheritance allows one implementation of the data abstraction to be related to another hierarchically. Now that's absolutely nothing to do with what I'm talking about this morning, except for the fact that this has a point of origin. Barbara Liskov, this is her paper in 1987. Has anybody heard of the Liskov substitution principle?
Yeah, that's all.
Yeah, okay, so this is the L, okay, Barbara Liskov, who received the Turing Award in 2008, and a kind of classic act of erasure. So a number of people said at the time, why is she getting an award for this? Everybody knows this stuff. Yeah, they didn't. This is some of the, she was given a Turing Award for a number of reasons, but one of the key ones, well, three things, distributed system stuff, language design, and paradigm stuff. Data abstraction came from her. Okay, this is a 1974 paper, Programming with Abstract Data Types. Look at the glorious typeface on that. Yeah, if you want to make something look retro, that's how you do it. This is genuinely retro. It's over half a century old. An abstract data type defines a class of abstract objects, which is completely characterized by the operations available on those objects. And you were going like, well, hang on, isn't this object orientation? Yeah, sort of. It's modern object orientation. Object orientation actually has a slightly different source, and encapsulation did not originally mean data hiding. That only came later because it logically sits with that. Encapsulation originally just meant these two things are together in the same capsule, the data and the behavior. It doesn't mean the data is also hidden. We have come to, well, it fits so obviously, but capsules have boundaries. So therefore encapsulation has come to mean that. By the way, don't worry, that's not a thing you have to worry about in the 2020s. It became that by the end of the 80s. So that's prehistory. Programmer is concerned only with the behavior which that object exhibits, but not with any details of how that behavior is achieved. And here is, to the best of my knowledge, and I've researched this one by actually reading papers rather than just looking at Google. This, I believe, is the first example of a stack data type as an abstract data. It's one of the standard TDD examples, one of the standard ADT examples, a very common object example. This is the first one, okay, 1974. And it looks like this. This is in a language, a research language called Clue, which also gave us like wild ideas like iterators. Yeah, familiar with iterators and yield? Yeah, that came from here, okay. Multiple assignment, familiar with that? Yeah, it came from here. Okay, so there's a whole load of stuff that Liskov and Co gave us in language design that we are still catching up with. Just for a bit of fun, I turned this into non-idiomatic Python. I tried to, the linter didn't like the fact that I wasn't calling it self, but I tried to kind of get it sympathetically close. And use a resizable array, in other words, a list. But I can also, and this is the interesting bit, I can make it out of composable tuples, or I can make it like a linked list that you find in Lisp. And all of these have exactly the same API. They have the same public interface. I had changed the internal representation because of data abstraction. Okay? The other piece in the puzzle here that Liskov was basing this off is the work of Parnas, 1972. So this is the early 70s. If you wonder what happened in the early 70s, this is it. It wasn't just a big lead up to disco and flares. Okay? On the criteria to be used in decomposing systems into modules, which I have to say is one of my favourite long-winded, classic, old-school comp sci titles. It immediately sounds important. Okay? So if you're looking to do a blog that sounds important, this is the format, okay? The decomposition was made using information hiding. That's what we're talking about. Excellent. As a criterion. Parnas is responsible for the term. Notice he puts it in quotes. Not because he's being ironic. That comes a few decades later. But he's kind of coining a phrase. He didn't actually. This isn't the first paper where he introduced it, but it's the first time he called it this. Every module is characterized by its knowledge of a design decision, which hides from all others. And this sounds exactly like encapsulation and all the other good stuff. It fits perfectly with data abstraction. Its interface or definition chosen to reveal as little as possible about its inner workings. Now, here we actually, the point is, there's something going on here, and it's very clever. It's a slightly passive instruction. Its interface or definition chosen to reveal as little as possible about its inner workings. To whom? So here's the paper where he actually explores it. This actually was published in 1971, ignore the 1972. It's actually published in 1971. Information distribution aspects of design methodology. Again, if you're looking for title formats to make you sound a little more important, this is the way to do it. But I'm going to take from the abstracts. This is absolutely fascinating. Some properties of programmers are discussed. He doesn't say some properties of programs. He says some properties of programmers. So I'm looking at the mirror, okay. I feel a little bit seen, but okay. What are the properties that are of interest? It's talking about documentation and knowledge that also exists within the source code. System documentation, which makes all information accessible to anyone working on the project, is discussed. We regard this as an unconditional good. But then he goes on to say, the thesis that such information broadcasting is harmful, that it is helpful if most information can be hidden from most programs, is supported. oh, that's what he means by information hiding. In other words, encapsulation, data abstraction, all these things play a part in this, but the underlying goal is I'm not going to tell you how this works. It's actually a matter of documentation. You come to a meeting and say, Kevin, how does that stack work? And I say, that is none of your business. Okay? That's a real, so information hiding is a much, so most of the time people want to say information hiding. I'm just going to say, substitute data for information. Far less pretentious. Okay, so let's talk about solid. I already talked about the L in solid. Listgraph is the only one that I don't have quarrel with. The others are either a bit wrong or really wrong. Like really wrong. I am not going to discuss the really wrong one. That's the O. That's just at 2 levels that you need to get something wrong. 2 different levels is fascinating. That's a different talk. I'll be back next year. We're just going to focus on this. SRP, which stands for? Excellent. Yeah, so that kind of works. And intuitively, that's not a bad name. That feels kind of comfortable. And we kind of see, this kind of echoes back through the history of software engineering. This is let's see, quarter of a century of Unix by Peter Sallis, and in it we find Doug McElroy's observation. This is the Unix philosophy. Write programs that do one thing and do it well. Yeah, this feels right. This feels like what we would intuitively call responsibility. The problem is that responsibility doesn't actually have a proper computer science meaning. I actually, just for a bit of fun, I went through that book that I showed earlier to find out how often we use the term responsibility. The book is, I don't know, 100,000. I mean, you can use it as a weapon or as a doorstop. It's a thick book. Responsibility occurs, well, I've got enough fingers on this hand to cover it. We are really clear about using other words. And that wasn't intentional at the time, but it's just like, it's a slippery concept. Because if you go back to the 80s and 90s, the general advice is a class should have no more than 3 to 5 responsibilities. Wait, hang on, that's a lot more than 1. So what's going on here? Actually, you know that naming is hard. This is how hard it is. It's not single responsibility, but it's what's the single reason for change. Reason for change, that feels really different. And Robert Martin says this. He says the SRP principle states the class or module should have only one reason to change. I'm finding this a little bit difficult, having actually done real software development. And it's like, only one reason for change? What does that mean? And he says the principle gives us both a definition of responsibility, which is completely unlike the definition that anybody would normally use. So I have an issue with that. At least he says this is my definition. It's a wonky definition and a guideline for class size. Actually, it doesn't, because if you follow his recommendation, he spent 30 years trying to explain what he means, and that is a sign of a poor principle. He keeps reframing this. And actually, if you take to a logical conclusion, which will please some functional programmers, it means you cannot have classes. Okay? If you want to go that way, that's absolutely fine, but that doesn't tell us an awful lot about classes. You can actually get a feel for this. Let's move from stacks to queues. So I've got a queue. Okay, great. And let's just say that another piece of code wants it. I want to pull things from a queue. I can call it pull, or I can follow a different consistency and say, I'm popping things from a queue, or I can dequeue using a different vocabulary. Now, the reason for change, is that technical or business? Is that architectural, personal preference, or user-centered? And the answer is yes. And I've just described 3 very different roles. It could be personal preference. On the other hand, it could come from, so in other words, personal preference is personal domain, but it's also technical. It's my technical choice. But it could also be imposed by another architectural decision. Naming conventions that you have to follow. Okay? If you are doing this and participating with this framework, you have to follow this convention. Okay? A very obvious one is if you're using PyTest, you've got to begin your tests with test. Yeah? So therefore, that's not in your control. So therefore, if you change the architecture, that's going to be a reason for change. Or you change something in architecture. Or it comes from the domain of the problem. So we've got 2 domains of the solution and 1 domain of the problem. That's already 3 different reasons for change, 3 different sources of change. Then we've also got how do we deal with errors. Now, I can say I align with the way that this will be consistently done within Python, or I can be domain specific. Or I can actually say that actually dequeuing is not an error. Okay, which makes a lot of sense for queues. Okay, I know that Python loves to throw an exception. It just raises them, like it raises the house, because it's just frustrating. It's just like, oh, you looked at me wrong, have an exception. But I'm not going to go that way. Because queues actually makes a lot of sense for this to be normal behavior. And the point there is that that's architectural, that is personal, and that is also a business or user decision. And we've got internal decisions, implementation. I can use a list and I can treat the last entry as the first, or I can treat the first entry as the first, or I can use a deck. The point there is that there's a lot of variation. Now, in doing this, terms introduced by Rob Martin, Martin described this as being based on the principle of cohesion, as described by Tom DeMarconi's book Structure Analysis and Specification and Myler Page Jones. I happen to be into old books, so I happen to have a copy of this one. This is the stuff. This is coherent. They had a system where they talked about coupling and cohesion. We're going to look at that, say 1970s. People do not produce book covers like that anymore. Okay. Cohesion is a measure of the strength of association of the elements inside a module. A highly cohesive module is a collection of statements and data items that should be treated as a whole, because they are so closely related. Any attempt to divide them up would only result in increased coupling and decreased readability. But this is much more meaningful. This is the principle you want. Don't muddle around with adaptations and variations. It's cohesion and coupling that we care about. Okay, so quickly, in the last couple of minutes, separation of concerns. Let us go to the internet. It's fundamental. We use that word earlier. It's a fundamental principle in software engineering and design aimed at breaking down complex systems into smaller, more manageable parts. Okay. Doesn't tell us how. The goal is to organize the system's components in a way that each part addresses a single concern. Okay. A cohesive aspect of functionality, rather than mixing multiple concerns together. Now, notice we've gone from the idea of general concern to here I'm talking software structure. We've made distinct, definite statements about software structure. So I'm saying that I'm really saying here that separation of concerns is about structure. Here we have a different claim, which I thought was fascinating. I thought I'd include it. Separation of concerns is also known as aspect-oriented programming. Yeah, it relates to AOP. I'm not going to give you an introduction to AOP, but it is not equivalent to. But again, design principle for separating programming into distinctive sections. This is a structural statement. We are looking at separation of concerns as a guidance for structure. There's nothing wrong with that, but I'm going to tell you that's not the whole story. And then, because it's 2025, let's go and ask the wisdom of AI, because nobody actually uses search engines anymore. They stop at the overview. Separation of concerns is a design principle that organizes software applications into distinct independent sections, etc. There's so much data out there that this is the summary. We're getting a message here about decoupling. Okay, so coupling, what's this one? See, it's a nice system. Coupling is a measure of the interdependence. This sounds really good. The higher the coupling, the more likely it is changes to the inside of one module will affect proper functioning of another module. Obviously, coupling is something we'd like to minimize. This is great. So, we've got coupling and cohesion. It's an interaction between them. Nice system. However, that is not separation of concerns. Or rather, separation of concerns, it's kind of a subset. Here's where it comes from. Edgar Dijkstra. 1970s, on the role of scientific thought. If you've never read any Dijkstra, it's quite a trip. We know that a program must be correct, and we can study it from that view. Must be. Should be. The rest of us would say should, but it's saying must. And we can study it from that viewpoint only. We also know that it should be efficient, and we can study its efficiency on another day, so to speak. But nothing is gained, on the contrary, by tackling these various aspects simultaneously. It is what I sometimes have called the separation of concerns, which, even if not perfectly possible, is yet the only available technique for effective ordering of one's thoughts that I know of. It is being one and multiple track-minded simultaneously. He's talking about it as a way of, as it were, kind of keeping focus, although he's a little strict about it. So I think separation of concerns is a valuable idea, though not exactly the way he describes it, but he's just using it as a thought tool. Because otherwise you get overwhelmed with stuff. He's not talking necessarily about a constructive piece of advice. We've already got that in terms of coupling and cohesion. So I will close with the observation from Russ Miles, a good friend of mine. Principles matter, but most of what we defend so ferociously are not principles. They're preferences dressed up in moral costume. I will be around at lunch to answer any questions. Thank you very much.